Welcome to the Math Practice Standards webinar series. This webinar will provide you information on the fourth mathematical practice standard, Model with Mathematics. Let's start by reading this math practice standard in its entirety. Then we will unpack it piece by piece. Mathematically proficient students can apply the mathematics they know to solve problems arising in everyday life, society, and the workplace. In early grades, this might be as simple as writing an addition equation to describe a situation. In middle grades, a student might apply proportional reasoning to plan a school event or analyze a problem in the community. By high school, a student might use geometry to solve a design problem or use a function to describe how one quantity of interest depends on another. Mathematically proficient students who can apply what they know are comfortable making assumptions and approximations to simplify a complicated situation, realizing that these may need revision later. They are able to identify relationships using such tools as diagrams, two-way tables, graphs, flowcharts, and formulas. They can analyze those relationships mathematically to draw conclusions. They routinely interpret their mathematical results in the context of the situation and reflect on whether the results make sense, possibly improving the model if it has not served its purpose. Math Practice 4 describes several habits that students should be proficient with. Let's break down each section so we can fully understand each of these proficiencies. The beginning statement simply means that students should be able to solve problems by applying math to everyday, real-world situations. In other words, the math needs to be something that's going to be outside the four walls of the classroom. This section describes the ability to simplify complex problems by making estimates and assumptions, knowing that later they will be revised. Proficient students can also identify relationships by using tools and analyze the relationship to get an answer. And lastly, this math practice states that proficient students can interpret their results and reflect on whether or not it makes sense and adjusting if needed. So although Math Practice 4 is lengthy when it's read in its entirety, it's really simply saying that students can solve real-world problems. They can simplify or revise their answers. They're using models and they're analyzing their results. So now that you have a clear understanding of what Math Practice 4 entails, let's move on to the implementation of this practice in the classroom. This will involve the necessary planning needed for authentic tasks and the problems to be incorporated in the lesson design. So what does Math Practice 4 look like in the classroom? Model with mathematics. The problems are tied to real-world examples or situations. Almost nothing is done in isolation. Every solution is derived from some type of model. It could be a map, a graph, manipulatives, tables, calculators. The list is endless. And the tasks that are given are rigorous tasks that need to be worked out and go beyond mental math. We must remember that modeling with mathematics is not a separate skill set. It is a habit of mind. Modeling should become a natural action that each student must execute as the search for solutions. These models should be practiced routinely. Just like a student has to practice playing an instrument or shooting free throws, modeling with mathematics and all of the math practices must be implemented often for proficiency to be obtained. The math practices should not be afterthoughts, but should be tied to the teaching of mathematics daily in all K-12 lesson designs. The National Council of Teachers of Mathematics, NCTM, has researched the impact of providing students with frequent opportunities with rigorous tasks. That research is what led to the layout of the math practices. We've gotten better at providing more problems and tasks, but now we are being called on to take a closer look at these tasks and identify what skills and habits they are asking the students to develop, and then provide the students with those that promote the development ascribed in the mathematical practice proficiencies. But how do we know that our students are developing the habits of mind that call for modeling with mathematics? We pose questions. We pose questions to the students, to ourselves, And eventually, we expect our students to pose these types of questions to themselves naturally. When we consider how to teach new concepts, the planning is paramount. This is the time where the teacher has to choose engaging tasks that will execute the concept and also instill the habit of mind of the math practices. When planning for Math Practice 4, Modeling with Mathematics, the teacher needs to question the tasks they develop. Are they engaging? Do they focus on real-world applications and problems where students can use estimation or make a chart, knowing that the first guess or attempt might need revisiting? And the tasks need to have time for students to model and improve models if needed. As the planning continues, teachers should ask themselves if the tasks chosen meet the following criteria: apply to real world, provide ample opportunities for different types of modeling, and do they lend themselves to representing multiple models as we provide direct instruction? This piece is extremely important. Students should be shown that different models can represent the same path to understanding. Questions teachers might ask when planning might include some of the following. Do the tasks I choose apply mathematics to everyday life? Do the tasks and discussions provide ample opportunities to model mathematical thinking? Do the introductory tasks lend themselves to multiple models? Do the student tasks lend themselves to multiple models? As we get better at asking ourselves questions during planning, we need to train students to ask themselves questions too. We want the students to develop lifelong habits. As teachers, we should ask the students these questions as they are engaged in the tasks, but the emphasis is on the fact that we want to help them develop the habit of asking themselves these questions. What do I know about this problem? Can I create a picture or model of this problem? What strategy do I think will work? Will estimation help? Did that work? If not, what else can I try instead of giving up? What about a graph or table? Is there a relationship within this problem? Does my answer make sense, and how do I know? And finally, do I need to revisit my solution? Now it's time to get more specific about the type of activities and tasks that will provide the desired habits of mind for Math Practice 4, Modeling with Mathematics. Think about this question. About how many children are in our school? The student that shouts out 100 isn't showing proficiency in modeling with mathematics. This question lends itself to many models. The long addition algorithm, a chart, a multiplication problem, a map of the school. All these models and many more can help a student solve this problem. And combine a model with a good understanding of estimation is also an indication of a strong math problem that supports Math Practice 4. Here's another task. Sam Houston Elementary School has nearly 1,000 children from kindergarten through 5th grade, with about the same number of students in each grade. No class has more than 25 students, but most classes are close to that number. What can you figure out from this information? Both of the examples on this slide and the previous one require assumptions and approximation to simplify, and also an essential step of reflecting on whether the results make sense. What's important here is not the context that's used, but the kind of thinking required. Using approximations to simplify a complicated situation can be valuable within mathematics and when exact answers aren't required. The point is that mathematical thinking simplifies the work. A completely different kind of modeling involves spatial location. A map or diagram models the real thing. This is an example of modeling distance in a 7th grade classroom. Make an imaginary town and label the different buildings with the correct coordinate points. Provide the buildings they must include and the coordinate point where that building should be located. And then you can see they have to plot town hall, fire station, library, ice cream shop, Central Park, grocery store, police station, and the gas station. This is more than just a 7th grade activity. Even children in kindergarten and 1st grade can lay out strips of paper in a grid on the floor, name the streets and avenues, place houses and schools and libraries at various locations, and describe the distances and directions to get from one to another. So here's another task. My box turtle is getting a new tank. He is 5.5 inches long and 3 inches tall. One side length of the tank needs to be 5 times his length. How long will the length of the tank need to be? In this example, students can use estimation to make the problem simpler, create a proportion table, or any other model that shows the relationship between the turtle and the tank. And this is a task that's going to be found in the real world. Now let's revisit a problem that we used in Math Practice 1 webinar. Again, so many of rigorous tasks will overlap with several math practices. In Math Practice 1 webinar, we pointed out how this applied to making sense of problems and persevere in solving them. Now we will focus on the model that helps students persevere to find the solution. Consider this question. What is 1/2 times 1/4? This is a standard question that would appear in any textbook or on any worksheet. But what does it evaluate? Whether a student can multiply fractions? Or does it evaluate if the student can reproduce the process of multiplying fractions? If a student answers 1/8, what does that really tell you? Do you know if the student understands which numbers represent the numerator or the denominator? Does the student understand that 1/8 is actually 1/2 of 1/4? That 1/4 had been cut into 2 equal pieces? Most students can provide the answer 1/8 due to learning a simple algorithm, but have no depth of understanding of what that algorithm really means. Models of this problem and others like it will make such a huge difference in the mastery of this concept. See how this task is different? It focuses on the use of a model. Create a picture that represents 1/2 times 1/4. Summarize how your picture represents the product of these two fractions. Can you see how this problem-solving task is much deeper? It provides a platform for many different approaches to the same solution of 1/8, but now each of the fractions has meaning because of the picture. Consider the academic discussion, the different entry points. What is 1/2? 1/2 of what? 1/8 of what? Are you sure? How does the model help you? Looking at a sample solution to the revised problem, we can see the depth of understanding. This new style of problem prohibits a student from just multiplying the top and multiplying the bottom. It calls for explanation, justification, and pictorial representation. Although the algorithm and process can be memorized, the model is what makes the difference in real understanding. Modeling with mathematics truly shows a student's depth of understanding. Now we will conclude this presentation with a quick discussion on how we assess Math Practice 4. Students can be assessed informally during this process just by asking questions as you circulate, which we talked about earlier. But some teachers want to use a more formal rubric or checklist. This rubric can be used or adapted as a quick reference to assist with the assessment. Model with mathematics. An emerging student can use models to represent and solve a problem and translate the solution to mathematical symbols. A proficient student can use models and symbols to represent and solve a problem and accurately explain the solution representation. And finally, an exemplary student can use a variety of models, symbolic representations, and technology tools to demonstrate a solution to a problem. It may be valuable to assess yourself as well. This rubric is a great planning tool as you design your lessons, or just use it at the end of a unit. As we become more self-aware of tasks we create, and if they are effective in implementing the math practices, we should see a direct impact on how students model with mathematics. As we conclude this webinar, consider planning tasks that require students to show their understanding through a model, using a graph, a coordinate grid, or a table. Also ensure that the types of problems you give students represent authentic tasks, real-world tasks that students might need to solve outside the four walls of the classroom. We hope this webinar helped clarify your understanding of Mathematical Practice 4, Modeling with Mathematics.